Welcome to the Explainer. You know, if you've ever been sitting in a meeting or a classroom and you find yourself debating whether to flip open your laptop or just reach for a trusty traditional notebook, well, you're definitely not alone. It's this everyday dilemma that pretty much all of us face in our super fast-paced world, right? Because on one hand, you've got the incredible speed and digital organization of a computer, but on the other hand, there's just that classic tactile feel of a pen on paper. But here is a question that might actually make you reconsider your daily habits. Is the absolute sheer convenience of digital typing actually causing you to forget things? Like, are we literally trading away our brain's ability to deeply encode information just because typing lets us transcribe everything faster? Okay, let's dive into this. It's undeniable that digital devices are rapidly replacing traditional handwriting everywhere, in classrooms, in offices, you name it. And for young kids, typing is often recommended because honestly, it's just less frustrating and it lets them produce text way faster. But there is a massive debate happening right now about the potential cognitive loss of completely abandoning handwriting. I mean, are we sacrificing crucial learning benefits just for the sake of speed? To find out exactly what happens under the hood of our minds, a fascinating piece of research set out to solve this cognitive mystery. Section 1. The investigation, peering into the typing brain. To get to the absolute bottom of this, researchers F.R. van der Wiel and Audrey L.H. van der Meer from the Norwegian University of Science and Technology set up this incredibly ingenious experiment. Their mission was straightforward but ambitious. Peer directly into the human brain to see exactly how it reacts to handwriting versus typing. So they brought in 36 young university students and had them perform two pretty simple tasks while monitoring their brain waves. The participants were asked to either type words on a keyboard using only their right index finger, or write those exact same words in cursive using a digital pen directly on a touchscreen. Now, you might be wondering why they were restricted to just their right index finger for typing. It's actually really clever. It completely prevented any unforeseen messy crossover effects between the brain's two hemispheres, which kept the data exceptionally clean. 256. That is the massive number of electrodes on the cutting-edge, high-density EEG sensor array worn by these participants. It essentially acted as this incredibly powerful magnifying glass for the researchers, allowing them to track brain electrical activity on a millisecond scale. So they weren't just looking at what the brain was doing generally, they were tracking exactly how different regions were talking to each other in real time. Section 2. The spark of learning, visualizing brain activity. So what did those 256 electrodes actually pick up? Well, the massive differences in the brain data between the two tasks are honestly nothing short of spectacular. Now, what's really interesting about this slide is the grand average coherence results contrasting the two actions. Look at those striking deep red bands lighting up. Those represent prominent neural connectivity in the lower frequency theta and alpha ranges. And notice how those red bands only truly ignite during the handwriting condition. Specifically, they appear between 1,000 to 2,000 milliseconds into the task. When participants were merely typing, that intense, synchronized neural fireworks display was largely absent. No way around it, the difference is night and day. We can actually see this neural symphony even more clearly mapped out right here. The researchers pinpointed exactly 32 significant clusters of activity, located primarily in the parietal and central brain regions. And here's the kicker. These specific areas only lit up with these intricate red and blue connectivity lines when the participants were writing by hand. It's literally a visual confirmation that the brain is working fundamentally differently and, honestly, much harder when you're holding a pen. But what does this crazy flurry of activity actually mean for us? Well, this synchronized activity is called theta/alpha connectivity coherence. I know, it sounds a bit dense, but just think of it as the brain's neural glue. When different regions of the brain synchronize their oscillations in these specific frequencies, they are effectively talking to each other to encode new information and form memories. In short, this coherence represents the actual physical manifestation of learning. And it was happening robustly during handwriting, but completely missing during typing. Section 3. Why handwriting wins. The power of the pen. This brings us to the why. If both tasks essentially just result in words on a screen, why on earth does the pen spark so much more brain connectivity? Well, the answer lies in the vast physical difference between the two tasks. So the crucial point is that handwriting involves intricate, precisely controlled shaping of individual letters. Every single letter requires a totally unique, complex coordination of fine motor skills.
Typewriting, by contrast, is just entirely repetitive. Producing an A requires the exact same simple, mechanical downward key press as producing a Z. Basically, typing trades sensory awareness and intricate motor control for pure, unadulterated speed.
And because handwriting requires such complex movements, it forces what neuroscientists call sensorimotor integration. When you write by hand, your brain is engaged in this continuous, highly complex sensory loop. You've got the visual input of watching the ink flow, the motor commands directing your fingers, and the physical, proprioceptive feedback of the pen pressing against the surface. Typing just completely lacks this rich, concurrent sensory pattern. And this brilliantly illustrates exactly what we're talking about. The sensory demand of handwriting forces the brain to organize itself into a highly connected functional network, which you can see visualized here as an adjacency matrix of distinct hubs and nodes. Because handwriting demands such high-level sensory motor integration, the brain literally has to recruit multiple different regions simultaneously to manage the complex task of shaping letters. It turns your brain into a hyper-connected superhighway of information. Now, this brings us to memory. Remember those low-frequency theta and alpha waves we saw lighting up in red earlier? Those specific frequencies are perfectly suited for long-distance communication across different parts of the brain. The researchers suggest that these low-frequency connections actually gate or lay the essential foundation for higher brain functions. They're basically the essential mechanisms required for integrating novel information and forming episodic memories. Handwriting naturally triggers this optimal low-frequency environment. Typing? Yeah, it just does not.
Section 4. The Classroom Connection, Practical Takeaways.
So, having uncovered these pretty stark neurological differences, how should we adapt our daily habits? First off, let me reassure you, the goal here isn't to throw away our laptops or totally abandon digital technology. But the data clearly shows that handwriting is absolutely critical for forming memory neural networks. Therefore, this ongoing trend of completely substituting handwriting with typing in educational settings is, well, kind of misguided and could seriously negatively impact the learning process. The real key takeaway here is cognitive flexibility. We just have to consciously choose the right tool for this specific task at hand. To help us out, the researchers lay out some very clean, highly practical advice for both students and lifelong learners who want to optimize their brain's retention. Step 1, when you're taking lecture notes, brainstorming, or trying to understand complex new concepts, pick up a pen. Let that sensory motor integration build the neural networks you actually need to remember the material. Then, step 2, once you've learned the concepts and you simply need to produce volume, like, say, writing a long essay or transcribing a document where speed is your main priority, then you should absolutely fire up that keyboard. To underline just how vital this all is, the researchers concluded their study with a really powerful plea. They state, "We urge that children from an early age must be exposed to handwriting activities in school to establish the neuronal connectivity patterns that provide the brain with optimal conditions for learning. If we don't build these neurological highways early on through the physical act of writing, we're literally depriving the brain of its most optimal state for absorbing the world." The science is clear on this one, folks. The physical act of writing physically changes our brains for the better. So as you head back to your desk or your classroom or your home office today, I want to leave you with one final thought to reflect upon. When was the absolute last time you wrote an entire page by hand?